So I'm going to give you on your test, I'm going to give you at least in one section, there are going to be several integration problems, and you're going to be able to work some and omit some. All right. So that formula sheet that I gave you, you need to have those formulas memorized. All right. The only ones that I'm going to put on the board are those 3 arc function formulas. And then make sure that you force yourself to go from the first thing you learn down to the last thing you learn. So if I see powers, whether they're roots, I'm going to think maybe it's power rule. It might be, it might not be. All right. If I see fractions, I'm going to think natural log first. It might be, it might not be. If I see e's, I'm going to try e's first. If I see trig, I'm going to think, is that one I have memorized? If it's not one I have memorized, I think, well, can I do some switching of something and make it one I have memorized? Is everybody with me? Josiah?
So on the first one, like if you didn't simplify it to 1/18, is that?
I'll just put -1. I mean, on pop test, I'll put a warning, but on your big test, I would put -1. Yeah, I will. We gotta have everything simplified. And anytime, if you're not sure if something's simplified enough on a test, just come ask me. Is this good enough? And I'll say yes, or I'll say no. Like, don't leave negative exponents, don't leave unreduced fractions, that kind of thing. Okay? Now, sometimes the book, especially when trig's involved, they'll do cute trig substitutions and all that. And that's awesome if you had your book or you had an infinite amount of time. But, most of the time I got stuff to do. You know what I'm saying? So I'm like, I'm going to simplify it to like what I consider to be reasonable, then I'm moving on. Okay? So don't sit there and fret about it. She's going to be satisfied. Just come ask me if it's good enough. And I'll say yes, or I'll say, I don't like that negative exponent, or make sure those fractions are reduced, or whatever. Okay. Now, for me personally, those arc functions are down toward the bottom, and you know me, U substitution is the very last thing. But for some of you, U substitution is way up at the top. Okay, so that's simply a personal preference thing. All right. Okay, so before we go to the homework, any clarifications on this one? Are we okay? All right, let's look at 23 on your homework. Okay. Let's see what 23 is. So I'm integrating, it's a definite integral, so I'm going from what, 0 to 1/6, is that correct? And then I've got 3 over the square root, is it 1 minus 9x squared, is that right? Did I copy it down right? Okay, so what's the first thing you notice when you see that problem? You've got a what? I've got a fraction. What else do you notice I've got? I've got a root. So I'm going to decide which one of those I want to do first. So for me, a lot of times I notice the root first. Now, if it's root, what do we do first with it? We change roots to what? Powers. Now, if we're going to do power rule, where's the root got to be? It's got to be in the what? In the numerators. Everybody with me? So in my mind, the first thing I'm thinking is this. Now, what power is that going to be when I change the root to a power? A 1/2, and when I bring it up, show how what's it going to turn into? Negative 1/2. So I'm thinking this, whether I write it down or think in my head. If it's power rule, I need the derivative of this inside, right? Okay, what's the derivative of that inside? Negative 18 what? X. What do I have? 3. Now I get the negative 18 with no trouble, but what can I not get? The X, so it's not power rule. But that's the first thing I thought. All right. The next thing I noticed was I did have a fraction. So I could be thinking, well, maybe it's natural log. But if it's natural log, remember, I need the derivative of the whole bottom. So do you understand the derivative of that whole bottom? That 1/2 would come down. My expression would stay the same. What would happen to my power when I'm doing derivatives? It goes down, so it's going to get down to a what? Negative 1/2. And then I have to have the derivative of the inside. So it's a whole lot more trouble. So there's sure no way I'm gonna turn a 3 into all that stuff. All right, so my first two things that I thought to try didn't work. Now, like I told you, substitution is way down on my list, so I'm thinking, okay, when else did I see a root on the bottom? Well, I saw a root on the bottom when I was doing inverse trig, didn't I? Now, do I have a number squared minus a letter squared or a letter squared minus a number squared? I've got an a squared minus a u squared, a number minus a letter. So is that arc sine or arc secant when you got a number squared minus a letter squared? That's arc sine. So in my mind, I'm going to write it like this. All right, what do you square to get a 1? 1. What do you square to get 9x squared? 3x. Okay. So if that's true, then I'm going to go to the side and write down what my a and my u are. I make less careless errors this way. What's my a? 1. What's my u? 3x. So remember, on top, if it's arc sine, I need the differential of u, correct? All right, what's the derivative of 3x? 3, but I also need to do what? X. But I look, and sure enough, what do I have on the top? I have a 3 and a what? Dx. So I don't need to do anything. It's just sitting there for me to do it. Now, if this had been an 8 and I needed a 3, I could have just taken that 8 and what? Pulled it out and then multiplied by 3 and a third. Is everybody with me? So if it's just a number problem, I'm always in good shape. But this one's already beautifully set up. So all I do is follow the formula. And my formula says that if I've got a du over a square root of a squared minus u squared, I get arc sine of what? U over a what? Plus c. And that would be written on the board. So I come over here and I just write it on the board. I need arc sine of u. What's my u? 3x over a. What's my a? 1, and then plus what? But now, what is 3x over 1? 3x. So I can simplify that to just 3x. So there's my answer. Now, that would be if it was indefinite. Is everybody with me? But it's not. It was what? Definite. All right. So we understand what's going to happen here. Instead of having a plus c, what do I have? I'm going from what? 0 to what? 1/6. Which one goes in first, the 1/6 or the 0? The 1/6. So I've got arc sine of 3 times what goes in first, you said? 1/6. Is everybody with me? And then minus arc sine of 3 times a what? 0. So I've got the arc sine. Now, what's 3 times 1/6? 1/2 minus arc sine, and 3 times 0 is what? 0. Now, this is going back to Cal 1. So does everybody understand? Arc sine of an angle is defined in 2 quadrants. It's either 1 and 2 or it's 1 and 4. So supposedly in Cal 1, you memorized whether it was 1 and 2 or whether it was 1 and 4. Do you remember which one it was? Well, let me tell you the way I used to remember it. It's got to be a positive quadrant and a negative quadrant. 3 is never an option in arc functions. In inverse trig, 3 is never, you don't have, never is at 3. It's either quadrants 1 and 2 or 1 and 4. Now, does sine depend on x or y? Y. All right. So quadrant 1 is always your positive quadrant. So where is sine negative in quadrant 2 or quadrant 4? Where is y negative? 4. Everybody with me? It's got to be 1 and what? 4. Because if you're in quadrant 2, don't you go up to get in quadrant 1, and don't you go up to get in quadrant 2? So in 1 and 2, the y values are both what? Positive. But if I'm going to 1 and 4, I go up, and then how do I get in quadrant 4? I go what? down, so that would make the y negative. So I know that I'm either in quadrant 1 or quadrant 4. Now I'm lucky because this is positive. So if it's positive, it can't be quadrant 4, it's got to be quadrant what? 1. So I need to know what angle has its sine to be 1/2 that's in quadrant what? 1. Now some of you have a unit circle memorized. Then you're just plucking it off. All right. If you don't, if you do triangles, then build it. What is sine in words like opposite, adjacent, and hypotenuse?
Opposite.
It's opposite over what? Hypotenuse. So that means that my opposite side must be a 1 and my hypotenuse must be a what?
2.
A 2. If you use Pythagorean theorem, that's going to force this side to be the square root of 3. And I think, oh, I know what that angle is. That's a 30, 60, 90 degree triangle. So which side's across from the 1, the 30 or the 60?
3.
The 30. And 30 degrees is pi over 6. 180 divided by 6 is 30. Now, common sense. Isn't the square root of 3 bigger than 1?
Yes.
Right? So think about it. If I have an angle, what happens to the side across from it when you widen the angle? The side across from it gets what? Longer, doesn't it? Well, so do you understand that the wider angle's got to be across from the longer side? So that's how I know that the 30's across from the 1 and the 60's across from the what? Square root of 3. So if you get confused, you should be able to do that now. So that's pi over 6 minus now. If it's 0 or any kind of increment of 90, it's got to come off the unit circle. Now remember what the unit circle is. The unit circle is a circle whose radius is 1 and the center is the origin. So if this radius is 1, what does it force this one to be? What point? What is it, 1, 0 or 0, 1? What point is that? 1, 0. What point would this be? 0, 1. This would be -1, 0. What would that one be? 0, what? -1. So because I know that arc sine is quadrants 1 and 4. In Cal 1, you should have learned that means that you've got to be between a -90 and a what? +90. Now you told me that sine depended on y, correct? Where is your y coordinate exactly 0 between here and here? Where? Right there. Well, what angle is that? Well, that's 0 degrees or 0 radians. And pi over 6 minus 0 is what? Pi over 6. See, Cal 1's a prereq for Cal 2, Trig's a prereq for Cal 1. Is everybody with me? Show up.
I think this is I didn't know this since Cal 1, but
Okay.
why didn't you say we need to have 1 negative and 1 positive when it's?
That's just the way I remembered it. In other words, inverse functions, the definition of an inverse function is it takes your domain and your range and it switches them. Okay, but it's got to stay a function. So remember what functions mean. Functions mean for every x, there's one and only one y. Does that make sense? So what happens though is a 1-to-1 function means for every x, there's one and only one y, and for every y, there's one and only one x. And so for your function to have an inverse, it's going to have to be 1-to-1. And here's the reason. All right, do we understand that like sine and cosine are a wave? If you were to graph sine and cosine, you get this wavy looking thing. Okay? So what happens is this function is not 1-to-1. It's a function because it passes the vertical line test. Okay? But 1-to-1 means it passes a vertical and it's got to pass a what? Horizontal. Okay, so here's what happens. I want you to think about it. I'm gonna put some points here. 1, 2, 3, 4, 5, 6. All right, remember, if this is a function, remember what an inverse function would be. An inverse function means the domain and range get what? They get flipped. So the inverse of this would be 2, 1, what? 4, 3, and what? 6, 5. That's still a function because for every x, there's one and only one what? Y. Now, if this, do we understand that, let's do it this way. This is still a function. Because for every x, there's one and only one what? Y. But it's not a one-to-one function. Because for every y, there's not one and only one what? X. So look what would happen if you try to do the inverse. When you do the inverse, this thing's not a function. So the only things that have inverses are not just functions, they are one-to-one what? Functions. So see, sine doesn't have an inverse. So here's what they decided. They don't use the whole sine function, they use part of the sine function. All right, do it this way. All right, this is 1,000 years ago. This is the way I used to do it. This is how before graphers. Let me show you. All right, remember my unit circle? Where I've got 1, 0, and what? 0, 1, and -1, 0, and 0, what? -1. Doesn't sine depend on y? Well, at 0 degrees, y is 0. At 90 degrees, at pi over 2, it goes up to what? 1. At this one, it goes down to, it goes down back down to what again? 0. Is everybody with me? All right, then it goes down to, everybody with me? It starts doing like this. All right, if I go backwards, if I go to a -90, it goes down to a -1. If I go this, it goes, all right, so we start getting this kind of thing. Do you see that if I chop it off between 0 and pi, it's still not 1-to-1? But what happens if I chop it off between -pi over 2 and pi over 2? That's 1-to-1. That's what they do for sine. So on sine, instead of using the whole graph, they just use it from -90 to what? To +90. And that is what quadrants, from -90 to 90 is quadrant 1 and what? 4. Now cosine, remember this whole graph shifts. So for cosine, they chop it off between 0 and pi, which is quadrants 1 and what? 2. So, and so the way I just remembered it was 1 was positive and what? It's not the reason for that, it just ends up, that was my memory trick, that 1 was positive and what? Now, here's the problem, with arctan, it's negative in 2 and 4. So my memory trick was, it goes with the numerator. So the numerator for tangent is sine. So since sine is 1 and 4, tangent's gonna be what? 1 and 4. So what I'm saying is, whatever memory tricks you come up with, you have to come up with. That was just Gann's memory trick. That might not work for you. Okay? But that's why memorizing things is great, and you need memory tricks, but even more than that, you need to understand why that's true. Okay? And so I still remember them talking about inverse trig the first time I saw it as a freshman in college and thinking, well, that sine can't have an inverse. It's not 1-to-1. So then it made sense when they went, well, we're just going to chop it off at a certain place. And that's what they did. Okay?
Thank you very much, ma'am.
All right. So what's going to happen basically is this on Thursday. Let's make sure we're clear. I'm going to be here at 7:30. Now, it should not take you longer than an hour and 15 minutes to take your test. But just in case you have a class after this one, is everybody with me? And you want to make sure that you've got extra time if you need it, I will be here at 7:30. Okay, so as long as you start the test by 8, within reason, you have as long as you want. All right, I've got a class that I teach in this room when this class ends. So if you're still working on your test, I'll just shove you to the back. Does that make sense? And let you keep working. Okay, so I'm not gonna, now if you come in at 8:01, I'm taking that test at 9:15. Okay, because you could have come at 7:30, all right? But if you need extra time, that's not a problem. I am going to give you one to do by the definition, guaranteed. All right, so that 5-step limit process, is everybody with me? So make sure that you go back and review that 5-step limit process, which means you better know the summation formulas, because they show up, remember, in that definition. There'll be a section like this one, like on the pop test on the board, where I give you a bunch of indefinite integrals and make you work some of them. Guaranteed, I'm gonna give you a physics application problem to do. So remember that worksheet that you worked on, where you know how high did the ball go, when did it hit the ground, how fast was it going? So make sure that you look over that physics application. Let's see, I'm looking at your homework to see what else they asked you to do. I'm looking back in 5-1. I haven't finished making it out yet, so. Oh, like on page 291, you know, where they would give you like the second derivative or the first derivative, and then give you particular, like f prime at 0 is 1 and f at 1 is 4, so that you can figure out what your c's were. Make sure you look over those. There's the definition. Make sure that you can find area. Now we're going to talk about area in a minute, and what we talk about today may be helpful to you. In other words, it wouldn't be necessary for you to use on your test Thursday, but you're welcome to use it. You'll see what I mean in a second. Okay, so make sure that you can find. Remember, if your whole box is above the x-axis, then the area between your curve and the x-axis matches the integration. If your whole curve is below the x-axis, remember your area is going to be the opposite of that integration. Okay, and if it's some above and some below, you're gonna have to break it up. I would be able to state the fundamental theorem of calculus. I've been known to just say state it. So make sure that you can do that. It's on page 318 in your books. Make sure that you can find the average value of a function. You know, we did that as well. Remember, that's the same thing as the definite integral with 1 over b minus a in front of it. I might ask you to use that second fundamental theorem of calculus if you want a shortcut where you take the integration and then take the derivative. Most of the rest of it's going to be making sure you know your rules and doing integration, some definite, some indefinite.
Well, we have to do that limit thing. Like
That's what I said, you have one to do by, it'll say by the definition. And that's what that means, you know, find your delta x, find your c sub I. There'll be just one of those, but there will be one of those. Okay. Now, I also gave you some review problems for homework. So does anybody, before we go into the new material, does anybody have a question about anything? Any homework problem you want to see from the new stuff or the review or anything like that? And I tried to grab kind of a variety of things from the review, but it's not guaranteeing that everything on the test is coming out of that review. That's just not possible. Okay. Or any clarifications before I go on? Okay, then let's talk about area. So we're going to be in chapter 7. We skip basically to chapter 7. We'll come back and pick some stuff up out of chapter 6, hopefully, if we have time at the end. But I've got to get certain things in, so if you go to Cal 3, you're not lost. Okay. Or 4. Now, all right. What if I told you that this was your curve? That's your f of x. Okay, and here's what I said. On your test Thursday, I can do this. Find the area between f of x and the x-axis on the interval, say from A to B. Now remember, those brackets mean include A and what? Include B. All right, suppose there's A and suppose there's B. So do we understand? I'm asking you to find this area right there. Okay, so how can you do that? What's the relationship between that yellow area and an integration? They're what? They're equal. All right, why are they equal? Because from x equals A to x equals B, this whole curve is what? Above the x-axis. So to answer that question, all you would have to do would be to integrate from A to B of whatever f of x what dx was. So you'd have to go find out what's the equation of that graph. Is everybody with me? Now, here's kind of the extension. So that first one came out of chapter 5. Now, this is what they're going to do in chapter 7. All right, that's f of x. That yellow curve is g of x. Okay, let's get a different color so you can see it better from the back. Make it orange. Okay. That's still A. And that's still B. But this time, this is going to be the question. Find the area between f of x and g of x on the interval from A to B. Now, before, it was always f of x and the x-axis. But now, instead of one of them being the x-axis, one of them might be the x-axis, but it can actually be anything. So what could I do to find this yellow area?
Integration of f of x minus integration like you get of g of x.
Okay, so I can do the integration of f of x. Now, does everybody understand that that integration is going to be from this red curve all the way down to the x-axis? Does that make sense to everybody? Then, if I integrate g of x dx, does everybody understand that that's going to be from this orange curve down to the x-axis? So if I take that whole red area and I take out the orange area, will that give me the yellow area? Yes. And that's what I can do. Does that make sense to everybody? Now that's if both curves are above the what? The x-axis. All right, well, let's try something else. Suppose they're not. Now, let me review this real quick, because this might be on your test on Thursday. Suppose I ask you on your test Thursday to find that yellow area. Between f of x, and f of x is this red curve, and the x-axis, and I want that yellow area. How am I going to do that? Yeah, in other words, I'm gonna integrate f of x dx from a to b, but this answer is not gonna match that yellow area. So Savannah says, if I want the area, I'm going to take this integration, then do what? Take the what? The opposite of it. Because this integration is gonna come out and be negative. Can area be negative? What? No. Well, what's the opposite of a negative gonna give you? A positive. Everybody okay? Now, so watch what they're gonna do next. Here's f of x. And here's g of x. Here's A. Here's B. And they want this area between the two. How am I gonna find that one?
Then the f of x, take the negative of g of x and add.
All right, if I integrate f of x dx from a to b, does everybody understand that that's gonna get me this part? We good? All right, so Shohab said, okay, integrate g of x, but what are you gonna have to do? Like over there, I'm gonna take the what of it? The negative. Is that gonna get me this area? And then what am I gonna do with those two areas? I'm going to what? Now, watch this. What's the same thing as adding a negative? That still works. That's pretty sweet. So this works when they're both above. This works when one's above and what? One's below. Let's see if it'll work when they're both below. All right, so what if f of x was there and g of x was down here? And again, I had an A and I had a B. And again, I wanted the area between the two. Which area is going to be bigger, the orange up or the red up? The orange up. So how, if I integrated this g of x dx, that would get me, what would I have to do to get the area from that orange to the x-axis? I have to take the what of it, the opposite. That would get me all the way from the orange up, wouldn't it? Now, what would I have to do to get the red up? I would have to integrate from what? F of x what? Dx, and then take the what of it again, the negative, right? That would get me this red area. All right, and what am I going to do with those two? I would have to what? I have to subtract them, right? This area what? Minus what? That area. Is everybody with me? What's minus a negative the same thing as? Plus or what? Positive. Is that still f of x minus g of x? So this works no matter what. Where f of x is the top function and g of x is the what? The bottom function. Now, let me show you what I'm suggesting that you do. This is going to save you a lot of trouble. I'd get some colored pencils or colored pens or markers or something. When we start, we're going to do area. From area, we're going to move to volume. And then we're going to move to surface area. all right, and arc length, it's gonna be crucial that you see, because they're gonna be sometimes 2, sometimes 3, sometimes 4, they're gonna be a whole different bunch of graphs, crissing and crossing. And you've got to know which one's on top. So the 2 things I would suggest for you to do to save yourself a whole lot of stress later is start drawing different functions in different colors, and always drawing what I consider to be what we call a representative rectangle. Now, what do I mean by that? Here's what I mean by that. They're going to ask you to do things like this. They'll say something like, find the area bounded by, and they'll say something like, f of x equals x squared plus 2, and g of x equals a negative x. On the interval from, say, in your book, they go 0 to 1. So you better make sure you have your graphers with you all the time, unless you want to be graphing all this stuff by hand. Okay, now, all right, what does this graph look like right here? X squared plus 2. What's that get me? A parabola. Now, am I graphing the whole parabola? What? No, I'm only graphing it from what? X equals 0 to what? X equals 1. Now, sometimes they'll even do it this. They'll put, I'll show you that in a second. All right, so do we understand? All I've got to worry about is 0 to what? To 1. I'm kind of making it bigger. All right, when you plug a 0 in there, what's 0 squared?
0.
Plus 2 is what?
2.
2. So 0, 2. All right, what happens when you plug a 1 in there? What comes out?
3.
3. All right. Now notice, I boxed it in red, so I'm saying this is my f of x function. Is everybody with me? Now, g of x is a negative x. Now, what is y equals a negative x graph? That graph of parabola, what's that graph? That graph's a line. Let's put it in purple so you can see a little better on the back. All right, and again, what happens when I plug a 0 in there? What do I get?
0.
I get a 0. So that's 0, 0. All right, what happens when I plug the 1 in there? What do I get? Negative 1. And I want the area what? Between them. Everybody okay? Now, I'm going to draw what I consider to be a representative rectangle. Now, most of y'all like vertical, are going to like vertical rectangles, and that's fine. I'm going to show you one in a second where I better do a horizontal rectangle. So I'm drawing a vertical rectangle in there. Now, here's the part I need you to start understanding. You have to choose between a vertical rectangle and a horizontal rectangle. And most of the time, you're probably going to choose a vertical. I'm not ever going to tell you whether to choose vertical or horizontal. You get to pick that. But if you choose a vertical rectangle, you have to do dx. And if you choose a horizontal rectangle, you just force yourself to do dy. And the way I remembered is based on the width of the rectangle. Okay, so when you're doing a vertical rectangle, the width is a change in x. Is everybody with me? And when we do a vertical in a minute, that's going to be a change in y. But you just need to memorize, if it's a vertical rectangle, you have to integrate dx, you have to use x's. If you do dy, you have to use y's. Now, here's the reason that color coding it works great. I need you in your mind to picture this rectangle anywhere in this shading. Do you see that it's always going to be red on the top and purple on the bottom? Because sometimes I'm going to show you one in a minute where it's going to change on you. And if it changes on you, you either got to flip your rectangle or do more than one integration. Now, if it's dx, it's always y on the top minus y on the bottom. If it's dy, it's always going to be x on the right minus x on the left. And if you learn that right now, your life's going to be infinitely easier when we get to volume, because it's going to be exactly the same. Now, what do I mean by that? I drew my rectangle vertical. So that means when I do my integration, I've got to be doing dx or dy. D what? Dx. If I'm doing dx, these have to be x numbers. So look on your shading. What's your smallest x to your biggest x? 0 to what? To what? 1. Now, if this is dy, those are have to be what? Y numbers. See, my y numbers would be running from -1 to what? To 3. So I've got to look at my highest and my lowest, my right and my left. So if it's dx, these have to be x numbers. If it's dy, these are going to be what? Y numbers. Now, since it's vertical, I'm going to write this down. You don't have to write it in, just look up here. Y on the top minus y on the bottom. I'm going to erase this in a second. I can't put y because this says d what? X. Don't be fussing about y'all getting variables mixed up in an integram. It's got to be one. If you switch to use, everything's got to go to what? To use. It's because I knew this was coming up. If this is dx, I can't have y's here. I have to have what? X's. All right. Well, look at your y on the top. Isn't your y on the top the red one? Well, on the red one, what's y the same thing as? X squared plus what? 2. So instead of putting y, what am I going to put? The y is what? X squared plus 2, the y on the red one. Minus, well, what's the y on the bottom? Well, that's on the purple one, isn't it? So again, I can't put y, I've got to put what? X. So on the purple one, what's your y the same thing as? Negative x. So instead of putting y, what am I going to put? I'm going to put a what? Negative x. That will get you that yellow area. Now, notice what happens. The integrations are going to be simple. So I'm going to integrate from 0 to 1 of x squared plus 2, what? Plus x. Is everybody with me? Okay, integrate x squared. What do you get? What happens when you integrate x squared? X cubed over what? 3. Plus, what happens when you integrate 2? What are you going to get? 2x. What happens when you integrate x to the first? What do you get? X squared over what? 2. And it's running from what? 0 to what? To 1. Which one do you plug in first? The what? The 1 or the 0?
The 1.
The 1. So I plug in, so I've got 1 cubed over 3 plus 2 times 1 plus 1 squared over 2 minus, now what am I going to plug in?
0.
So I've got 0 cubed over 3 plus 2 times 0 plus 0 squared over 2. Is everybody with me? Now, what's this whole second one going to? That just goes to what? 0, doesn't it? So what have I got? I've got a 1/3 plus a 2 plus a what? A 1/2? What's my common denominator going to be between 1/3 and 1/2?
6.
It's going to be 6, isn't it? What's 1/3 the same thing as? Isn't that 2 6? And a 1/2 is a what? 3, 6, so what's my final answer gonna be? 2 and what? What's 2, 6 plus 3, 6? So I get 2 and what? 5, 6, that's my final answer. That's my area. Okay? Now, what if I give you one like this? All right, I've got a y equals, let's do this one. 2 minus x squared and y equals x. Find the area between those curves. Okay, so the first thing I'm going to have to do is I'm going to get my grapher or by hand and graph it. All right, so if I get my grapher, what's this first one going to graph for me? What's y equals 2 minus x squared going to graph for me? What? So get your graphers out and graph it. All right. So I've got 2 minus x what? What? Now you knew you were going to get a parabola, right? But the grapher does all the work. Do you see your vertex is 0, 2? Now, this thing is coming down somewhere. I've got to be careful. It's coming down somewhere a little to the left here and a little to the right there. Is everybody with me? That's actually the square root of 2 and the negative square root of 2. All right, so is that what your graph looks like on your graphers? Now, here's your other graph. Y equals what? X. Now, what is y equals x graph? Well, I'm going to graph it on my grapher too. Don't you get, you should get a line that splits quadrants 1 and 3 in half. Is that what you get? So you got some kind that looks like this. Is everybody with me? That's what your graph should look like. Is that what's on your graphers? Now, what do I want? I want the area of what? Between them. Well, now I'm going to have to draw a representative rectangle. And again, let me show you why I want to do it vertically. I'll show you in a second what happens if I try to do this one horizontally. Then I'm going to do a horizontal one real quick. If I decide I want to do a vertical rectangle, am I going to have to use dx or dy? I'm going to have to use what? D what? When it's vertical? Dx. Then what kind of numbers have to be my A and my B? They've got to be what kind of numbers? All right, what's the X running from under shading? Well, it goes there to what? To there. So I need the X coordinate right there and I need the what? How am I going to find these X coordinates? How am I going to find what these points are? That's where those two graphs what? Intersect. So do we understand that the Y on the red is the same thing as the Y on the purple? And the X on the red is the same thing as the X on the what? Purple. I mean, that's what the X is the same thing on both of these and both of those and the Y's. Well, it's no problem to put Y equals Y, but that doesn't help me any. Is everybody with me? What is the Y on the red the same thing as? 2 minus what? X squared. What's the Y on the purple the same thing as? X. Now this one's more helpful for me because this is a quadratic equation. How do you solve quadratic equations? what do? We factor. Now, I don't care. Most people seem to like their square term positive. It doesn't matter to me. But if you like your square term positive, you're probably gonna want to move everything over here. Is everybody with me? So that's gonna be what kind of x squared? Positive. X is already what? Positive. If I move this 2 over, I'm really subtracting 2 from both sides. It becomes what kind of 2? And then it equals what over here? 0. Now, this one is all sweet, it factors all pretty. Now, what if it doesn't factor all pretty? What are you gonna have to use? Quadratic equation, but this one does. What does this one factor into? X what? Plus 2 or plus 1? Plus 2 and minus what? 1. So that says either x plus 2 is 0 or what? X minus 1 is 0. Well, x plus 2 is 0 when x is a what? Negative 2. X minus 1 is 0 when x is a what? 1. So that means this must be the point negative 2 comma something, and this must be the point what? Now, if I needed the y values, how would I get them? I'd plug them into my graph. Now, would you rather plug them into this one or that one? That one. But do I need to get the y's on this particular problem? No, because I just need the what? The x's. So my smallest x is a what? Negative 2, and my biggest x is a what? 1. Now, do you see that no matter where I draw this rectangle, if I draw it vertical, I've got red on the top and what? Purple on the bottom. So do we understand that's going to be y on the red minus what? Y on the purple. Why can't I leave it y? Because it says what? X. So I say, okay, what is the y on the red the same thing as? 2 minus what? X squared. And what's the y on the purple the same thing as? X. Now, I'm not going to finish that because you should be able to do that integration. So the integrations are going to be easy. It's going to be the setup that's a little more challenging. Now, do you understand that if instead I decided to draw a horizontal rectangle? Do you see up here I'd have red on the right minus red on the left. And then down here I'd have purple on the right minus what? Red on the left. So you see it changes colors? That means I'd have to do 2 integrations if I want to do horizontal. So you're like, well, I'm never going to do horizontal. Yes, you will. All right, let me show you when you would. They show you one in your books on page 448. Okay. I'm not going to take time to do the whole thing. Just want to show you something real quick. We'll do some more on it. Here's one of your graphs. One of your graphs is x equals 3 minus y squared. Now, I want to make sure we're clear about your graphers because this happens all the time when somebody's doing this on a test. How do you make your grapher graph that? You have to solve for what? For y. So do you understand that y squared would be 3 minus what? X. So what's y? If you do the square root of 3 minus x, you're only going to get half your graph. Because this actually solves into this. So you're going to have to do 2 different graphs to make your calculator graph it. If you graph y equals the square root of 3 minus x, all right, then what you're going to get basically is you're going to get half of your graph. You're going to get this one. And when you graph y equals a negative square root of this 3 minus x, then you're going to get the bottom half of your graph. Because you should know this is gonna be a parabola because one thing is squared. When the x is squared, it either opens up or down. When the y is squared, it opens right or left. All right, then the other graph they wanted you to graph was this one. X equals, and they do y plus 1. Which looks like this. And they want the area between the two. So do you understand that if you do it vertically, if you draw it here, you've got purple on the top and what? Red on the bottom. But if you draw it over here, you've got what? Red on the top and what? That means you have to do 2 different integrations. Instead, if you decide that you want to draw it horizontally, no matter where you draw it, you would have red on the right and what? Purple on the what? Left. So if you draw a horizontal rectangle, you're gonna have to do what? D what? dy. So that means now, what kind of numbers are these gonna be? They're not gonna be x numbers, they're gonna be what? So when I find these intersection points, now I don't need the x's, I need the what? The y's. And it's gonna be x on the right minus x on the left. But why can't you have x's? Because you have what? D what? Y. Well, x on the right is x on the red, isn't it? What's your x on the red the same thing as? 3 minus what? Y squared. All right. And then minus. And your x on the left is your x on the purple, so that's going to be y what? Plus 1. And again, that's going to be an easy integration to do. But you've got to do the same thing we did over there to find these intersection points, and then you're not going to have x's here. What are you going to have? You're going to have y's. Now, one real thing before you go. Sometimes you're going to have to do more than one integration no matter what. Now, what do I mean by that? I mean, what if I did this to you? And I told you to find the area between the red one and the purple one. Do you see that if you draw your rectangle vertically, let's make it a different color. Anywhere over here, you're gonna have purple minus what? Red. When you get over here, what are you gonna have? Red minus what? Purple. I'm gonna have to do this integration and then do separately this integration and then do what with those two answers? Add them. And you say, well, I'll do it horizontal. Well, that's gonna be worse. Because horizontal, you have purple minus purple, red minus red, over here, red minus red, and what? You see what I'm saying? It's not gonna help you to flip them. Okay? Now, what's your homework assignment going to be for next time? To study for your test. I'll be here 7:30. I'm gonna go ahead and put some homework up for like Thursday night, but don't even look at this area homework until after you take the test. But do you see that one of your graphs could be the x-axis? That could be your f of x and your what? G of x. So you can even work the old ones this way. All right, what's your equation for the x-axis? Y equals what?
0.
0. Then you might have like something like x squared plus 2. Is everybody with me? Okay. I'll see you if you need some help. I will see you Thursday by 8 o'clock.